I'm going to run through some examples of basic things you need to know for the Chapter 3 test. First thing is how to find slope of a line passing between different points. And there are all kinds of different equations you can use for this. You can use y2 minus y1 over x2 minus x1, probably the easiest thing to do. It doesn't matter what order you pick your points in. I like to line my points up. I like to write out my two values like this. Remember that every point, you have a first point and you have a second point. Every point has an x and a y coordinate, so that's an x1 and a y1, that's an x2 and a y2. So the formula says you're subtracting the 6 and 4, the way I've got mine set up, and you're subtracting the 3 and the negative 1. Make sure you subtract a negative, and that gives me 2 over 4. Always want to simplify your fraction, and final answer ends up being 1/2. If I want to graph, a couple different ways that I can graph. First of all, I can graph by finding x and y intercepts. And remember that to find an x-intercept, you can set the y value equal to 0. And to find a y-intercept, you can set the x value equal to 0. So for example, if I want to graph an equation like 2x minus 3y equals 6, really, as long as you know it's a straight line, and this will be a straight line equation, really, you just need the 2 points that you can plot the quickest, and it's very, very easy to substitute zeros into an equation and find points. So for example, if x is equal to 0 here and I want to find the y-intercept, that's going to leave me just with the statement that says that negative 3y is equal to 6, because I'm going to have 2 times 0, which is 0, minus 3y equaling 6, and that means that y is going to equal negative 2 when x is equal to 0. So I can plot the point 0, negative 2, and that's going to be a point right here. Or I can set the y value equal to 0. That value is going to go away. I'm going to be left just with the statement that 2x is equal to 6, because it's going to be 2x minus 0 equals 6 when you substitute in a 0 for y. X will end up equaling 3 here, and of course that was when the y value was equal to 0. So the x-intercept will be at 3, and I can draw my line passing through those 2 points. So that's relatively quick, relatively easy. Of course, I can also use slope-intercept form, and that is also known as y equals mx plus b form. That's the basic equation for graphing. A lot of times you're going to get equations that aren't written in that form. So for example, if I've got something like negative 4x plus 5y equals 10, I need to basically need to solve for the y variable here. So I don't want the negative 4x over on the left side. I can add 4x to both sides. In this case, that's going to give me 5y equals 4x plus 10. Those values are both positive. Notice y, still not isolated. Need to divide both sides by by 5. Everything gets divided by 5 when we divide to make sure that that equation balances. We get y equals 4/5 x plus 2 when you simplify that out. And then relatively quick and easy to graph that. Remember that is the y-intercept. The fraction in front of the x, once you've got it in this form, is the slope. And of course we know that slope is a rise over a run, or a change in y over a change in x. So you go up to the y-intercept at 2, and the slope is 4. So you go up 4 over 5. 1, 2, 3, 4, 5. And your line is going to be passing through those 2 points. And certainly you can plot more points if you need to, but 2 would be the minimum required. Now, other things to know. Lines are perpendicular if their slopes are, you can call them either negative reciprocals or opposite reciprocals. So for example, if I have a line with a slope of 3, as a fraction that's 3 over 1, the negative reciprocal would be negative 1/3, and so those lines would hit at a 90-degree angle. That's something kind of important to keep in mind. Now, if I want to write linear equations, the easiest way to do this, unless you just happen to know what the slope is and what the y-intercept, the easiest way to do this is going to be to use what's called point-slope form. Point-slope form comes from the equation for slope. It looks a lot like it just kind of moved around. The formula is y minus y1. y1 is a constant y-coordinate, is equal to m, the slope, times x minus x1. x1 is an x coordinate. And basically I can put in my slope in the position of m and put in my x and y values for x1 and y1, and I'm going to have the equation of a line. So for example, if I want a line passing through the points, actually if I use my points from before, I had -1, 4, and 3, 6, and I know it's going to fit into the form y minus y1 equals m times x minus x1. You can pick either point you want to substitute in. For example, I could pick the -1, 4. That's going to be an x value of -1, and I can fill that into the equation. It's going to be a y value of 4, and I just need to find the slope. If you remember before, we already found that slope to be 1/2, and so the equation is just going to be, the equation is going to be y minus 4 equals 1/2 times x minus -1, and of course we know minus a -1 really becomes plus a +1, and so your equation looks like that. You can multiply that out, and you can put that into slope-intercept form if it's requested, although it's not required. So I could multiply both of those by 1/2. That would be 1/2 x plus 1/2 is equal to y minus 4. And then I could add 4 to both sides, and you're going to get y equals 1/2 x plus 4.5. And then you would also be able to see the y-intercept here at 4.5 in addition to the slope at 1/2. So again, not required unless the question specifies that something needs to be written in slope-intercept form, but it's something that can be useful. Other things that are important, didn't mention this before, but when you're dealing with slope, remember that a horizontal line is going to have different x values and the same y values, so maybe points like 3, 1 and 5, 1. Now if you go through the slope formula here, it's going to be 1 minus 1 over 5 minus 3, which is 0 over 2. That just simplifies down to 0. So a horizontal line has a 0 slope. A vertical line will have the same x values. It'll have like points like 2, 5 and 2, 10, something like that. y2 minus y1, that's going to be 10 minus 5 in this case. On the bottom, x2 minus x1. And notice in this case I get 5 divided by 0. If you think logically about this, division is really asking how many times 0 goes into 5. It can go in infinitely many times, so we don't have a number that represents that. We say that that slope is undefined. If you try to divide that out in your calculator, it's actually going to give you an error. So a vertical line has an undefined slope. We talked about the little skiing example. If you skied off a vertical slope, you would die. So it's undefined as a skiing slope, also undefined as a slope of a line. So that's also a useful fact to know. I could describe various types of things and ask you to write the equation of a line. For example, I could ask you to write the equation of a line passing through the point -2, 5. I'll focus here a little bit. And perpendicular to the line 3x minus 5y equals 10. Something like that. And same kind of thing. You can use point-slope form. And I need a point. Well, I've got a point. My y value there is going to be 5. My x value is going to be -2, so that's really easy. Only thing I need to do is find the slope. And of course we know that the slope can be found by putting this equation into slope-intercept form. I have 3x minus 5y equals 10. I want to get the x on the other side, so I'll subtract that. So don't lose your negative sign. That's negative 5y equals negative 3x. Negative 3x plus 10. Divide everything by negative 5. And your final equation is going to be y equals, the negatives will cancel, we'll have positive 3/5 x minus 2. I don't really care about the y-intercept here. I care that the slope is equal to positive 3/5. Okay, so the perpendicular slope is going to be the negative reciprocal. If the original slope is 3/5, the perpendicular slope is going to be negative 3/5. And that, of course, is my missing value that gets filled into my equation. So final equation is going to be y minus 5 equals negative, oh, I'm sorry, wait a second, opposite reciprocal. Sorry, it should be negative 5/3. So it'll be y minus 5 equals negative 5/3 times, gotta slow down when I'm doing this, sorry. It's going to be y minus 5 equals negative 5/3 times x minus negative 2. And of course that minus negative 2 really is just going to become a plus. So it ends up being an x plus 2 there. So a little messy there. Y minus 5 equals negative 5/3 times x plus 2. And again, you could multiply that out. You could write it in slope-intercept form. It really doesn't need to be written in that form, however. Next problem I want to look at is off section 3.1. It's the plane problem. The plane is flying at an altitude of 32,000 feet. Drops 25,000 feet over the next mile of travel relative to the ground. So, in other words, 25,000 foot vertical drop in comparison to a 5,280 horizontal drop. And I want to know how many feet the airplane will descend as it travels 1 foot horizontally. A couple things here. First of all, just to visualize what's happening, you can always make a quick sketch of this kind of thing. If I'm graphing this on an axis, what's really happening here is when this plane starts out, so I have an x-axis and a y-axis. When this plane starts out, the plane is 32,000 feet off the ground. And it says that it drops 25,000 feet relative to the ground over the next mile. Okay, so it's going to drop 25,000 feet. And of course, if you drop 25,000 feet from 32,000 feet, that takes you down to 7,000 feet. And that's over the next mile horizontally. So it drops 25,000 feet in a time in which it travels horizontally 5,280 feet. So the plane is going through something kind of like this. Well, remember the slope is a rise over a run. Okay, it's not rising this time, it's dropping vertically 25,000 feet over the course of the time that it moves horizontally 5,280 feet. Certainly I can simplify this down a little bit as well. I can divide out the zeros here. And divide both of these by 2. It's going to be 1,250 over 264. Those both divide by 2 as well. So you get 625 over 132. Hopefully that's simplified. And that would be my slope. So if you look at this thing, it's really starting out 32,000 feet up. I could write an equation in slope-intercept form because I've got a y-intercept and I have a slope. So that would be y equals 625 over 132x. Oh, by the way, that was a drop of 25,000 feet, so that should be negative. This should all be negative. The slope should be negative, plus 32,000 being my y-intercept. And I can answer most questions using that. Now, it does ask me how many feet the plane will descend as it travels 1 foot horizontally. Well, horizontally is an x value, and so I could substitute that value in there. You have to be careful. It's going to give you out the y value. It's going to give you out the new height. The new height won't tell you how much it descended. The new height's going to tell you where it ended up. So I would have to subtract to do that. The other way you can think about that is you can really just set up a proportion here. I know that the slope is negative 652 over 132. In other words, it drops 625 feet for every 132 feet it moves horizontally. And so I can also do that. If that's a rise over a run, it's asking me how many feet it will descend. That's a rise as it travels 1 foot horizontally. And I can cross multiply here and solve that little proportion. I get negative 625 is equal to 132x. And so it's going to be negative 625 over 132 equals x. Actually, that's a little misleading. I use an x. That's a rise value. Might actually want to call that a y. Might want to call that a y down here. But basically, it's going to drop 625 over 132 feet. So again, I could divide that out. That's approximately 4.7 feet in that time, but that's a rounded value, so I would prefer to have it left in this form right here, even though it doesn't give you quite as easy of a visualization. Part 2 asks you what will be the plane's altitude after it's traveled 660 feet relative to the ground. Well, relative to the ground, 660 feet is an x value. So for an x value of 660, I want to figure out its new altitude. Well, remember this equation I wrote up here is the new altitude. So I can actually substitute my 660 in for x, and I can solve that. That'd be negative 625 over 132 times 660 plus 32,000 equals y. Remember, y is an altitude. Now, unfortunately, it doesn't say whether or not this is supposed to be rounded or not, so so that would be negative 412500 over 132 plus 32,000. Again, really depends on whether or not you're supposed to simplify this or not. As a rounded answer, that would be approximately 28,875 feet. Actually, it wouldn't be approximately, it would be exactly. That worked out nicely. And so that's going to be the new height. Of course, the other thing you could do, you could set up a proportion. You could set up a rise and a run. It's a negative 625 to 132 rise over run. You want to find out how much it will drop when it has moved horizontally 660 feet. And so you could cross multiply here. You can get 660 times 625 divided by 132, and y is going to be negative 3,125. Now that's the drop, okay? So you're going to have to subtract that from the 32,000. So it would be the 32,000 minus the 3,125, And of course you get the same answer we had over here. So you can do it either way, just purely using the slope and finding the drop. But again, having a picture, knowing that your equation is giving you the altitude instead of the actual drop, those things are all important as you go through these problems. But that's the basic idea there.